In this video I'm going to give you a brief description about thermistors and LDRs and also explain some of the practicals that you can do with these types of devices. On screen now is the symbol for a thermistor. Okay, so a thermistor is basically a thermal resistor, so its resistance depends on temperature. A higher temperature will supply more energy to the electrons so they're able to move more easily within the material. That reduces the resistance in the circuit, which means you can get a larger current to flow. It's a practical investigation that you can carry out with a thermistor. So you can see here that we've got a thermistor which is in this point here, which is inside the beaker we've got covered in oil. We've got a thermometer which you can see is the yellow part there, and then we've got a multimeter that's going to measure our resistance in ohms. Connected to our thermistor we've got a 50-watt heater, which is this part here, into the circuit, and what we're going to do is we're going to increase the power rating of the heater to try and increase the temperature of the water. When the water reaches a certain temperature, we're going to measure the resistance of the thermistor. So what we're expecting to see is that the power of the heater is increased, the temperature of the thermistor increases, and that decreases the resistance. So we expect the resistance observed on the multimeter here to go down. These are the types of results you'd expect to get for a thermistor. So remember that the resistance depends on temperature. Higher temperature leads to less resistance. So you can see for our graph as the temperature increases, our resistance increases. Note that this is a non-linear relationship. If we wanted to plot a graph over this side, where we've got I, which stands for current, remember, we can see that it's the opposite relationship, where as the temperature increases, the current also increases, but again, in a non-linear way. Use of thermistors then. So thermistors are used as temperature sensors, so that can involve anything from keeping the temperature of a greenhouse constant, keeping the temperature of an incubator constant, set to keep the temperature of a swimming pool constant, or to try and turn on heating systems when the temperature gets too hot. In most new buildings of schools, there will be thermistors that control the temperature of the school. So thermistors are useful as temperature sensors because changes in resistance are measured. A change in resistance leads to a change in current. If resistance decreases, the current could flow to turn on a heater or a fan to make sure the temperature doesn't get too hot or too cold. And that's how you use thermistors. So you would connect the thermistor into the circuit with the component you wanted to control, and as the resistance of the thermistor changes, that would change the current, and those electrical signals can be detected by devices to turn on or off a fan or a heating system. Moving on to LDRs then, so they're light dependent resistors. For an LDR, the resistance depends on light intensity. As the light intensity increases, more energy is supplied to the electrons so they can move more easily, and that reduces the resistance in the circuit. As the resistance decreases, remember, that causes an increase in the current. Here is a simple LDR investigation. So you can see that we have a light source here, known as our array box. Okay, we've got an LDR over here, which is our light dependent resistor. We've got a light meter here, and we've got an ohmmeter or ohmmeter there, which is basically a multimeter that's connected to our LDR. And then we've got our ruler here to measure the distance. So it says here, as the distance between the light source and the LDR increases, the light intensity will decrease. This causes an increase in resistance. The reason the resistance increases is because as the light intensity decreases, the electrons inside the LDR receive less energy, therefore they can't move around as much. That reduces the current. Now remember that the current is a rate of flow of electrons, or rate of flow of charge. So the slower the charges are moving, or slower the electrons are moving, the less resistance you have. So what results would we expect to get from this experiment? So the resistance depends on light intensity. Higher light intensity leads to less resistance. So you can see here as light intensity increases, we get a decrease in resistance, but again, it's in a non-linear way. In the same way that as before, where remember I is current, as the current increases, as the temperature increases, the current will increase because current is the opposite to resistance. So resistance opposes the flow of electrical current, and obviously as that opposition decreases, more current will flow. So here are some of the different uses for light dependent resistors. You can see you can have automated street lights, automated room lights, burglar alarms, automated blinds, and digital cameras. We're just going to look at the digital cameras as a way they work. So in digital cameras, LDRs are also useful for controlling how long the shutter should remain open. Change in resistance are measured, and if the light level is low, the shutter stays open for a longer period of time than if the light level is high. So what you've got there, remember, is that the change in light intensity will cause a change in resistance. The change in resistance means that there's a change in current, and the change in current can be measured electronically by a device, and that can either turn on or off. If you take the example of street lights, what you've got there is a decrease in light intensity. Okay, as the light intensity decreases, what you're going to get is the resistance of that product is going to increase because of the electrons receiving less energy from the light, and therefore, as the resistance increases, what you have to do is you have to have that connected in like a parallel circuit so that more current could flow around, therefore turn on the light. And it's the same in each of the other cases as well. And that brings us to the end of the video.